First question says, actually, let's not do the question.
Should I
Let's
copy
first
down,
talk
like,
about the
read some
fundamental
ABs,
counting principle.
read some pre-count?
Huh?
Let's not get into that.
Just
Okay.
The fundamental counting principle says that if an event M can occur M a number of ways.
Oh yeah.
So if an event M can occur in M number of ways, followed by another event N that can occur in N number of ways, then to find the event M and then N to happen, you multiply M times N.
I already
It sounds
did this.
really confusing because I just keep saying M and N. So I'm just going to talk about the example and how it relates to the fundamental counting
Very
principle.
cool.
So let's say you have 3 pairs of pants
Okay.
Oh my god, we used to do this in middle school.
Was
and
it
you have
easy?
2 shirts
Yeah.
and you want to know how many outfits you can make with the shirts and the
Oh my god, I used to make little like
Yes.
diagrams.
Yeah.
So if we were to
I
make a
used to have, like,
diagram, we could wear
like
this shirt
marbles.
with this pants, this shirt with this pants, this shirt with this pants.
Yes, that's what I did.
Then we could do this shirt with this pants, this shirt with this pants, this shirt with this pants.
We did this in pre-algebra.
And so what you're doing is
We're basically
you're doing
multiplying.
you're doing each pant with each shirt and like each pant with each shirt.
Oh, I hated
So
this.
instead of just making a
It's
bunch
like
of
a-
diagrams, which it works, but obviously if the numbers are bigger, it'll take you a longer time.
I still
You
use
can just
diagrams
take
a lot of
the possible pant amounts and multiply by the shirt amounts and get 6.
Or you just count them all.
So literally, we're just gonna multiply. So 3 times
So
3
have-
times 2 would be you try.
If you've ever seen,
I fell
Alright,
asleep.
so
at,
the
like,
lunch
11
menu
morning.
consists of 3 sandwiches,
Oh, very cool.
Why do I actually enjoy
Let's go.
this?
3
This
sides,
is fun for me because it's literally multiple.
and 2 desserts.
What?
How many different meals can you assemble?
But like I'm still
18.
copying on the first question, so we must.
And how'd you get it?
3 times 3 times 2.
So there's 3
I love
sandwiches, there's 3 sides, and there's 2 desserts. And when you multiply those together, you get 18 meals.
Wait, I thought sandwiches was spelled WHICHES.
You know,
Like my
I
mom.
could be
That's-
wrong,
that's the
but
other which.
I think I'm just combining the other which with
I'm not the best
sand.
speller. So instead of making a diagram, this is what you can do. Now this is assuming, I should say, that you're getting a sandwich, a side, and a dessert. Like that's assuming you get all 3 of those things. If you didn't want a dessert, then no dessert would be an option.
So that would be a fourth
If you
option.
didn't want a side, no side would be an option. And if you didn't want a sandwich, no sandwich would be
So
an
then it's
option.
just like
So
4
that would
times 4
add
times 3.
exactly.
16
So if
times
not
4.
getting one of those items is an option, then it would be 4 times 4 times 3 instead.
16
There'd be
times
more like possible
Better.
meals that you could get.
What if you want
Wait.
2 sandwiches?
Huh?
What if you want like 2 sandwiches?
Ooh, then
Don't talk.
that
about
would be like a 5th option.
That's.
Just
That
like,
would
don't
that
go-
would just
don't
make
think
it
about that part, just
complicated. Then you have to pay extra.
Yeah.
Did you bring food this morning? For what? For the.
Yes. Oh my.
Wait. What was? Wait, 3 times 3 times 2?
Yeah, I don't have my phone.
How do you do that?
I got to-
You just literally just do that?
Actually, no.
So 3 times 3 is
Just
9
listen
times
to
2 is
the
18. There's only 18 possible combinations. That's it, really?
But yeah,
It's
I
assuming that you
Why
get
are
Was
you-
the answer
one of
18?
each.
Yes, choose me.
Oh, okay. Okay.
Alright, so in example 2, it says in 2004, Maryland license plates consisted of 3 letters and then 3 numbers. How many different license plates can be made with this layout? So
9.
how many letters are there?
Sorry, I didn't need to go away.
26. So the number of ways that M could occur is 26.
Oh my god, why?
That would be the number of ways that M could occur. Then M is going to occur again
26.
and again.
26. And then there's
Then
infinity.
how many numbers are, well, how many single digit numbers are there?
9.
9.
So there's
0.
Oh, 0.
0
There's 10.
and then
because
1
there's
through
0.
9. So
Well,
that's
there's all the way up to
technically
Google
10.
Plex.
So then there's 10 ways that N could occur, and then N is gonna occur again, and then N is gonna occur again.
Yeah, I'm gonna have to pull out my calculator.
Yeah, I'm gonna have to do that as well. 'Cause I
This
don't
just
know what
happens
that
to be one of those times.
You know, I think it's fine.
is. So 26 times 26 times 26 is.
Are you sure it's times 10 and not 9?
Well, Brandon, you count 0.
No one counts 0. No one.
But like you do, like I swear.
Oh, you do? Okay, I swear too.
Yeah, because number 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 0.
See, the only issue
Got it.
is I thought there was 24 letters.
Well, yeah. What happens if I
That's
don't know
a
how
big
many
number.
Sarita said
No, that's how many.
26, and
That's how
I
many
was like,
teeth
yeah,
you
that
have.
sounds right.
No,
That's
usually
what
you have.
Million.
Usually you have about 24 teeth in your mouth.
F, G, H, I, J, K, L,
She's just gonna
Usually you have
verify.
about 24 teeth.
R, S, T, U,
If that's what
V,
you're getting
W,
confused
X,
with.
Y, Z.
28.
Are you counting? Oh my god,
I have
A
28 too.
permutation is a vocab word. Ready? Permutation.
There's 7 of
I
them.
only
Emma,
had
stop
20
counting your
Sorry, I
teeth.
only had 28 and I was really lost.
We're not gonna finish
I had
this
28
section if you
too.
don't pay attention.
7, 7, 7, 7.
Right.
14, 14.
Right.
Okay.
A permutation
Okay.
is an arrangement in which order matters. So, for example, if I was like, everyone get in a single file line. When you get in a single file line, you get in that line in an order, yes?
Probably.
I suppose.
If I was like, y'all get in groups, when you get in groups, you just
Y'all.
kind of coagulate. And it doesn't really matter what order you're in.
Right.
That would be what's considered a combination. So that's what I was saying before, is the word combination in math doesn't mean just like a arrangement. It means like an arrangement in which order doesn't matter.
Why is there an
Permutation.
exclamation point at end?
I'm getting there. A permutation is an arrangement in a particular order. So in order to do some of these questions, we'll need to know what a factorial is. So a factorial, if you ever look at a calculator, there's a little exclamation point button somewhere. It's not just to say like, oh my, exclamation point. It's like an actual math thing. It's a symbol. So what it means is to take the number that comes previously, or yeah,
Mine moved
previous it,
nothing.
and then to multiply it by each preceding number. So if you have, say, 5 factorial, you're gonna multiply 5 times all the preceding numbers until you get to 1. So
Mine, like, really
4,
doesn't have-
3, 2, and 1. That would be what 5 factorial is.
So like 6 would just be 6 factorial.
Exactly.
Oh, I remember that. Oh, yeah.
And so some of what we do is just like simplifying factorials. So let's say we had 5 factorial over 3 factorial. Instead of doing 5 factorial divided by
You just
3
do
factorial,
2 factorial.
we can do, right, because
Oh, don't you have
5,
to include
4,
0?
3, 2, 1 would be
No.
5 factorial.
Don't you have
And
to
then,
include 0?
shh, no, 3, 2, 1 would be 3
3
factorial. And then these would cancel with these, and you'd get 5 times 4, which is 20. So some of what we do involves simplifying factorials. So that's how you would simplify factorials. So
Okay.
this is not necessarily this.
I found it.
Sometimes in some situations it could
It's
be
120.
coincidence that that's the case, but these are not equal.
So it's
Okay.
literally
Nailed it.
okay.
So you would have to go through the process. You would take away the factorials that they overlap. So let's say we have like 10 factorial over like 2 factorial. So 10, 9, 8, 7, 6, 5, 4, 3, 2
7,
factorial.
6.
2 and 1 will cancel.
Is that a 2, 6 or 7, 6?
And then over 2 factorial. The 2 factorial will cancel with 2 factorial, and then all you have to do is the rest of those. I mean, I say all you have to do. This is a lot of numbers, okay?
Is there gonna be
Uh,
like large numbers like that? Cause like that's a little excessive.
Sometimes, but let's say
Oh,
it's
we have
like
calculators, right?
100 factorial over 99 factorial. So 100 factorial is 100 times 99 factorial over 99 factorial. 99 factorial cancels with 99
Just
factorial and you
100.
get 100.
Oh.
So it's only annoying if this bottom number is a lot smaller than the top
It's just
number.
like weird looking.
It is indeed.
Weird looking.
Like me.
So the way we compute a permutation is with these factorials. So let's say the question is, in how many ways can you file 12 folders, one after the other in a drawer, right? So you put files in, I don't know if you've ever seen like a file drawer, you're like, like they're in an order, perhaps in alphabetical order if you're fancy. So all we're gonna do is 12 factorial because we're putting them in a single like line. So we're doing like 1, 2, 3, 4, 5, 6, like a single line. It's just gonna be 12 factorial.
0, do you want me to tell you?
Sure.
479001600. It's a large number,
This is a really big number.
but I think it's fine.
Do we even have to multiply by the 1 at the end? Because like, come on, let's be honest.
Not really.
Not
yeah.
really, but I mean,
But your calculator, so everyone take a second
it's right here.
and like try to. Those are simple permutations where you're just doing things that are one after another. Things in a closet, 1, 1, 1, 1, 1, 1, 1. When I said before, single file line. So if there's 10 of you, how many different ways can we get a single file line? That would be 10 factorial.
Are we gonna have a quiz just on this stuff? Because that'd be easy.
I don't know. I don't remember.
Please make it this easy.
Now, if we make that more complicated and put in like extra numbers, like you were saying, Christy, we have to use. So I do believe.
Jubilee.
Hold on, pause. Menu, and then probability, and then permutations. You'll see this notation on your calculator. If you're trying to calculate something like this, in parentheses you'll put the numbers like 10, 3, something like that.
Oh, I have it. I have
We're
it.
gonna
Oh,
do
do
it
you really?
both ways.
Yeah. What do I do?
We're gonna do it both ways, one way with the calculator and without. So this is if you're taking your arrangement and arranging it kind of more with more conditions, I would say, I suppose. So like instead of us just like getting in a single file line, what if we're erasing?
You subtract.
The whole class, let's go outside. No, we're just kidding.
Let's run it.
In how many ways can 10 students finish first, second, and third? So we don't really care about like what happens fourth, fifth, and sixth, and etc.
Yeah,
We
don't
just
care
have
We
about-
definitely
care
have our
first, second, third.
calculators in our quiz, right?
Not if it's something like this, we wouldn't need one. So this is what we would do. We would take n factorial, that's the number of students, factorial, and then we would do 10 minus, since we're worried about first, second, and third place, 10 minus 3 factorial. And this is like the notation for that. So you could type this in on your calculator, or you can go through this process. So to go through the math, what you would do is subtract 10 minus 3, that would give you 7 factorial.
It's just 10 times 9 times.
And then we would simplify like I showed you before. So like 10, 9, 8,
10
7
minus
factorial is 10 factorial. When we divide by 7 factorial, the 7 factorials cancel. 9 times 8 is 72 times 10 would just add a 0. So that would be 720 ways our class could people could finish like first, second, and third in a race. So it could be like one, it could be like it could be like see what I'm saying? There's a lot of ways.
Wait, are you erasing it though?
I don't race.
Oh, okay.
Actually, Madison's not here, so I have to.
Oh, that's not good. Wait, we have 10 people. Do we?
No.
I'm just kidding though.
Do we have any? No, 10.
Madison's in Tennessee.
So if it says how many ways can someone win first and second, what's the difference?
It would
It's just- it would be 2 the R is 2.
The R is 2. So, and then it says among the 14 students, so we're gonna do
I'm on Fortnite.
14
a
over
permutation of 14 people
2.
taken twice, and that's gonna be, go ahead and simplify.
We're gonna have 100.
Whose all this sneeze was that?
That was mine.
There's a different way to sneeze, there's no need, after uni there was something.
My bad, Mr. Elgato.
Alright, so 14 minus 2 is 12.
You're showing trouble for sneezing.
So we would do 14 times 13 times 12 factorial divided by 12 factorial
Cheers.
is equal to 14 times 13, which is, what'd you say, what?
182.
182.
182.
I have a question. What happens if like the 12 is on the top and the 14 is on the bottom?
12 is on the top.
Like
and
what if
14
like the
on
top
bottom.
is smaller than
That
the
wouldn't
bottom?
make sense. You can't
It will
arrange.
never be smaller than the bottom?
Can't arrange 2 people in like 14 like doesn't make sense.
Okay.
How do you
Two
get
people
negative
can't come in
ways?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 place.
Never happened.
Makes
So
sense.
it doesn't make sense.
It's like,
If you go running a race and you get like negative numbers, then
this,
it's probably
that means I'm
Would the exclamation point be like squared?
No,
Like.
no. Alright, so in math, the word combination is to arrange things where order doesn't matter. So don't get confused between the math word combination and the like English word combination, because they could be used for questions like this, but not necessarily mean the same thing. Order doesn't matter when you pair people up. So how many different ways can 14 people pair up? That's 14 people paired up.
2.
There's 2 things, like 2 people in a pair, right?
So I did it right so far.
We can read this as 14 choose 2. So if you ever hear that, that's like how you would read it. cast. Instead of like 14C2, we say 14 choose 2.
Oh, just like you say, like, if there's a Z in like a name, you say Z.
I don't say that.
Well, that's like a Canadian thing.
Yeah. Alright, so what we would do is we would take all 14 people, factorial, and we would divide that by 2 factorial times 14 minus 2 factorial.
Whoa, buddy.
I know. I just like stopped once I simplified that. 'Cause
It's
I
not
was
that
like-
bad.
So now we're gonna work on simplifying it, like pretending like we don't have a calculator. So we would
Yeah.
simplify
Think just one.
14 minus 2, that would be 12. And then, remember 14 factorial is like 14, 13 times 12 factorial.
Very cool, very cool. Ooh.
And 12 factorial and 12 factorial will cancel each other out. Then we could also take a look at 2 factorial, which, as Braden said earlier, like 1 doesn't really do anything, so we can kind of ignore the 1. Simplify just the numbers 14 and 2. So how many times does 14 go into 2? Or 2 goes into 14?
7.
So we would cancel. And then now what we're doing is just 7 times 13. So that's 70 and 21. It's 91 ways.
91, yeah.
You know, this is
So try to simplify as much as possible if you don't have a calculator. But that is also on your calculator if you go to menu. And then probability combinations.
when are we having this quiz?
I don't remember.
Monday,
You can do 14, comma 2,
Tuesday, or Wednesday?
and you get 91.
We usually have the Wednesday.
Yeah, probably. Probably Wednesday. Sometimes it's on a Friday.
Okay, try, you try.